Welcome to Robotics and Automation News webinars, where you can be part of a global event without leaving your home or office. Attend our live webinars and communicate directly with influential professionals in your industry.
Hello, my name is Abdul Muntakim. I'm editor of Robotics and Automation News.com. In this interview, I speak to Mike Harper, Vice President of Sales and Marketing at AutoGuide Mobile Robots. AutoGuide provides vehicles for material handling in warehouses and production facilities and is part of the Teradyne Group. Mike discusses a wide range of topics, including what the differences are between an AMR and an AGV, and how the two types of vehicles are becoming similar.
This is Mike Harper. I'm the Vice President of Sales and Marketing at AutoGuide Mobile Robots, and I spend my time looking at new applications for heavy payload automotive or automation projects in the automotive, manufacturing, and warehousing space with our team of sales and applications engineers headquartered out of Boston, Massachusetts.
Right. And AutoGuide is quite an interesting company for me because I first, I think, heard of them or came across press releases about them a couple of years back. And they then got acquired by a larger company. Do you want to give us a little history of that, if you don't mind, of the recent couple of years?
Certainly, yes. Prior to November 2019, AutoGuide was a smaller independent company developing an autonomous mobile robot, an AMR, for these heavier payload applications, mainly tugging and then handling pallets, loaded pallets. And this caught the eye of Teradyne Corporation, who has had an initiative to grow in the industrial automation space for several years, starting with their acquisition of Universal Robots several years ago, and then following that up with MIR, Mobile Industrial Robots. And then the AutoGuide offering fills the space at the higher end of the mobile AMR spectrum. And in November 2019, they consummated the acquisition of AutoGuide, and AutoGuide became part of Teradyne's Industrial Automation Group, thus rounding out sort of the collaborative robot, the cooperative style robot space that Teradyne focuses on.
And has this changed? I don't know how long you've been there. Sorry, I may have missed it. But does that kind of thing change the nature of your job if you're marketing or selling to clients or potential clients? It must improve your standing if you're part of a larger company or not. I mean, how do you see it?
Mm-hmm. Yeah, it's a good point. Yeah, I joined the company right after the acquisition, specifically to take advantage of my background in industrial robotics and to really try to tap into that synergy that we have with the Teradyne Industrial Automation Group. So yes, we do. We enjoy a global footprint, for example, of service depots and locations for, after sales service. We spend time in collaboration with our sister companies in sort of technology and new application considerations and spaces like that, and then not to mention just the financial backing that we get from Teradyne that does allow us to invest in these cutting edge technologies that we see coming into the space and take advantage of that. So we do feel a real sense of empowerment in being part of Teradyne, and so it is different, I guess, significantly than being a standalone company located in the U.S. and trying to grow in a more of a bootstrap fashion than the conditions that we're in today.
Yeah, I find Teradyne quite interesting. One day I should try and arrange an interview with someone there to talk to them, because they're essentially now a very large robotics company with several acquisitions. Just one technical question before I get onto the list of questions that I mentioned. I wanted to clarify what you mean by AMR and how it differs from AGV and things like that. What's your understanding of what AGV and AMR is? The reason I asked that question is obviously a lot of our readers will know the difference between the two, but that difference isn't necessarily the same as it was before. The distinction isn't, it's being blurred. So some AGVs are acquiring more computing power and becoming more autonomous. So they're looking a bit similar. So I wondered what your perspective was.
That's a good way to put it. The line, so to speak, is sort of being blurred, I think, with new technology. So our definition, or my definition, is more of the classic one, and that is that an AGV is typically a line-guided vehicle via magnetic strip, in the part of the infrastructure of the plant or the warehouse that we're operating in. So it follows that path specifically. It's a very accurate way to drive a vehicle, but lacks sort of flexibility then to be used in an autonomous fashion. Where the AMR, the autonomous mobile robot, it has onboard navigation that relies on features in the facility to provide its positioning feedback so that it can go where it needs to go. And so it doesn't rely on a strip in the floor, but rather relies in the case of AutoGuide and natural features in a plant. Those would be columns or racking or features that are stationary and that present location points that we can navigate from. And then the vehicle is freer then to navigate via multiple different routes, for example. It's not combined or constrained to a single route. It can also adapt based on the inputs from the system controller to change its routing if needed be. It can be sent on various types of missions from the same point, or can terminate missions at different points depending on the need of the overall system. So the AMRs come across as a more flexible, more easily deployable system that does not really require infrastructure enhancements or changes to make the system operate. That's the basic definition that we ascribe to.
Right, and from that, I understand that, or at least I think I understand that essentially yours are AMRs, a certain level of autonomy. They're not necessarily AGVs in the traditional sense that you described initially. They're actually AMRs, but the AGV traditionally was designed to carry heavier payloads. So I'm guessing that your AMRs do have that heavy payload capacity, high payload capacity, and that means that they're kind of quite different from the AMRs and fairly, the new startups, I guess you could call them, the AMRs with much lighter payloads are bringing out. So what are the differences or unique things about your AMRs?
Sure, absolutely. Yes, our AMR is a larger payload class, and I guess the definition then that we use for AMRs applies to anything from automatic vacuum cleaners in your home, all the way up to autonomous vehicles that are running on the roads that are having to make decisions in real time based on input. So our classification of our vehicles is those that are typically moving higher payloads and handling those payloads themselves, and not necessarily interacting on a regular basis directly with a human, as say a cobot might do. And so some of the smaller industrial AMRs are meant to bring totes and various devices and things to human operators and interface with them more directly. We are more focused on moving materials around and handling logistics and delivery operations with higher payloads, whether they be palletized using one of our AMR fork trucks, or whether they're on trailers that are pulled by our AMR tugger configuration. And so moving those loads around from place to place in a facility is really where we focus on, and specifically in the higher payload range. Those things that are, say, 1,000 pounds and up are typically the middle of our application sweet spot, so to speak. Does that answer the question?
Yeah. I think
Okay.
there's such a large market, growing market, and so many interesting things are happening. We could talk about different aspects of it for a long time, but we'll try and limit the interview. I usually ask too many questions, so I hope you don't mind. So one of the other questions I'm going to ask is about AMRs versus other forms of material transport technologies. I mean, I've done a few stories about how warehouse operators are sometimes, or have been over the last few years, faced with the choice of whether to install conveyors or go with AMR technology. And obviously you would know better than I that with conveyors you're talking about fixed infrastructure and the advantages of maybe fast moving things. But AMRs, sorry, did I say AMRs? I meant conveyors. That's fixed infrastructure, and you got mobile robots, which obviously enable you to be more flexible. You don't need as much infrastructure in place, fixed in place. So yeah, what kind of conversations have you been having along those lines? I mean, are there people that you've talked to that are faced with such choices, and how do you maybe try and persuade them that your solution is more appropriate or better?
Right. So that's a great question, because we deal with it every day, and it really boils down to the use case that the client or the company is trying to deal with, and it's really kind of stems back to a classic automation situation where you're looking at a choice between, say, or the continuum between a continuous flow process, which would be your traditional roller conveyor, where you could potentially have product rolling in a continuous fashion, continuous stream of pallets, continuous stream of totes or product, all the way to the other end, the asynchronous side of that, where you have things that are done in quantum loads, like on a pallet in a specific tote. And these things are not coming or needed in a continuous fashion, or maybe more importantly, they're needed to be delivered to other places within a facility or other locations that is asynchronous to what a normal continuous flow might be. So we offer a very cost-efficient way to take materials that are in deliverable form from their source, and call it as maybe a single source in a plant, to any one of many locations, whether it be a loading door to go into a truck, or whether it be into a storage facility for storage for later on, or whether it be into a racking system for a pull order system. So having the vehicles gives you that flexibility that you simply don't get out of the fixed conveyor. And so the use cases will dictate pretty quickly what the right technology is to go and deploy. So this is a tugger configuration where these trailers are obviously very flexible to be configured for what you'd like to do. But this, if you imagine, performs a similar function to a conveyor. It takes product from one position to another position, and can do it in a very flexible manner, very suited to, for example, just-in-time production facilities where you want product to arrive at a certain place in a production line or a manufacturing environment at a specific time in a flexible manner. So you can do that very easily with a trailered configuration, and you tow that then with a tugger.
I didn't realize that you had, well, there's six sections here, six. I
Mm-hmm.
didn't realize you had so many different solutions. That's just the hardware.
Sure,
We've got control software here. But before we get onto that,
sure.
I did ask you about specialty robots. You anticipated it and you talked about it. So I appreciate that. But yeah, it's a very interesting, obviously, really, really interesting area. There's a lot of development
Mhm,
going on. What would you
mhm,
say some of the technical changes have been for AutoGuide in terms of maybe since being becoming part of Teradyne, maybe
sure.
has there been any technical upgrades, changes, or anything like that to the
hmm
robots or the systems?
hmm Yes, yes, there have, and that's a great point because the position in time when Teradyne acquired the company was exactly the right time for us on our technical roadmap. So a major difference in AutoGuide and virtually every other heavy payload AMR company is that we've intentionally chosen not to take sort of a copycat approach where you take a traditional manual vehicle and you put a control kit on that vehicle and then you automate a previously manually operated vehicle. We've rather taken the traditional industrial robot approach and built this Max N platform, which is a base vehicle. It's a robot, so it's a base vehicle with the ability then to adapt to a tugger uh, uh, connection or the high bay lift that you see on the screen or a standard fork truck connector to it, or in several cases, a specialty trailer for a manufacturing environment. So, from the mechanical side, the innovations that we're seeing are these use cases that are coming out of the need to automatically handle material, and where we mechanically then develop the tooling, the application tooling for that hooks onto our Max N base platform, and then we can now go off and automatically do material handling that previously was very manually oriented. So that's part of the solution. I think the other part is that our configuration by having a base vehicle that's a robot is it opens up this vast opportunity for us in the software space, and so we are constantly adding new functionality via software. We're adding new ways to deal with data from, the WMS system coming into our system or our feedback back to that system. Onboard troubleshooting, artificial intelligence hooks that we have. So it's a our approach allows for us to grow both on the mechanical side to adapt to the material handling needs, but then also on the software side, that really does add value to the overall automation solution when you can simply just do more with the robot that you've already developed. And so
Can I
we're
just
growing in both dimensions. Yeah.
Yeah, just quickly, sorry to interrupt. Just quickly ask you, the warehouse management system that you've mentioned here,
hmm
is that, you mean that in a generic sense, whatever the
Yes.
client has, they might have a different
Yes.
variety of different warehouse management systems, or do you supply one of your own, or what?
No, we don't. We do not supply one of our own, but we do integrate into the customer's, uh,
Right, okay.
SAP or one of the, any WMS system that comes in there. Once we have that interface map laid out, it's fairly easy for us to use the SurePath enterprise controller there, that second device,
Yeah,
to configure that. Yeah,
that's your thing, isn't it? The
that's
SurePath,
correct.
yeah. Is that a
Yeah.
software solution or is it software plus hardware? I mean, I know the robots are involved,
hmm
obviously, but
hmm
is there anything between them? Is there like a hub or some sort of device between the computer and the robot?
Sure. So our control algorithm, we put the SurePath control software resides typically on a virtual machine on a VM in the customer's facility, and it communicates via Wi-Fi to the SurePath client, which is resident then on each of the Max N vehicles. So
Right.
each vehicle is a client of the SurePath system, which then allows for great scalability in number of vehicles that are on fleets. We have fleets running with dozens of vehicles on the same system, controlled by one SurePath enterprise control system.
Now, the amount of data obviously goes up with each machine or each robot
Mm-hmm.
that you add to the system. And what are the network issues perhaps going forward, if not now? I mean, the volume of data must be quite large that's being passed around the system from the computer to the robots and back. And is there any sort of cloud cloud involved? I mean, I suppose the warehouse management system might be hosted in the cloud. But yeah, what do you know about the data rates and
Mm-hmm.
volumes about
Mm-hmm.
in this sort of scenario?
Sure, that's a good question. Yes, the answer is technically, according our testing and things that we've done, the cloud-based environment is certainly altogether possible. It just so happens that the most of the clients that we deal with much prefer the on-premises style control for their system. So this is the preferred deployment at this point in time, but who knows where it's going to go with customer preference then in the future. And then as far as, handshaking back and forth, the vehicles have a tremendous amount of intelligence on them as far as how they're going to navigate between points. And as we assign a mission to a vehicle, then really the only communication between the vehicle back to the SurePath controller is simply the handshakes to say, yes, I'm on path. Yes, I'm where I'm supposed to be. And yes, I have confidence that I'm on task for where I need to be. In other words, the SurePath controller is not driving the vehicle in real time over the Wi-Fi during its mission, but it is in constant contact with it. But the vehicle itself has the ultimate intelligence to do it, to learn its route, or to know its route, and then to follow that route based on the waypoints, in the facility. So that's one of the strategies, I believe, that's key to being able to add many vehicles onto the same system and to work in a very coordinated fashion on one system. Is you can't take all the bandwidth for real-time navigation and expect to be efficient. You just can't do it.
So sending back data about which turn it should make or what obstacle it should avoid, those are kind of things that are on board, because it would take too long to send a question back to the computer, much less the cloud, and get an answer back about things like that. Those are things that other people have told me, and it is very interesting, but it still kind of intrigues me to, I wonder at what point maybe there would be cloud control robots, whether the network would be fast enough, because then you could have less onboard hardware and software. There'd be less to do on board, making those robots possibly cheaper, or there might be some other reason for it to be a good idea to have cloud control robots. I don't know what your perspective is. That something that you see as being a good idea if the cloud can handle that sort of request about left, right turn and collision avoidance and things like that? Is there an advantage to cloud robotics from that point of view?
Yes, I think certainly at the enterprise level, having a centralized control, there's the collection of data is in one place. The visibility across the enterprise to what the fleet is doing, those are all very good advantages, I think. And if we kind of take a step back and look at what's the priority around an AMR, especially a large AMR, safety is first, right? So as long as the safety system is local to the vehicle, doesn't rely on cloud communication to react to obstacles or intrusions into the safety envelope, that type of thing, then the trade-off becomes, okay, what is the overall fleet performance based on where this cloud is, or this cloud control does it? Is it limited by the number of vehicles? Is it limited by does it limit the speed a vehicle can go simply by the need to check in at a certain interval or that kind of thing? And so then continue that line of thinking, it goes down then to processor and communication speed, to optimize that, to make it, a cloud based control the same as an on-premise based control, really just comes down to the ability to transfer data at those same baud rates, at those same rates that you get locally. Can you get that across the cloud? And as we see in technology, things are getting faster all the time. So along with that comes a reduction in infrastructure cost, the hardware cost, and things like that. So there is motivation to do that, and at AutoGuide, we're looking into that in our engineering department. We've conducted a number of tests, and we want to really understand the implications on looking at a different control scenario. And there's in different kinds of control technology, or different kind of communication technologies out there, right? There's satellite communication, there's cellular communication, there's obviously Wi-Fi communication. So each of these types of communications have their own input into what their version of cloud control could look like. So it's a vast open space right now.
Yeah, it's a very interesting question. I don't know what the advantages of cloud robotics would be in a scenario like this, and the vulnerability of, if you do go to cloud, as you're saying, the network is wide open to, possible hacking and things like that. So that's another issue. But yeah, it's a very interesting area. There may be advantages. Certainly as I say, the hardware doesn't need to be sophisticated on board. If it's all centralized, then all it needs to do is, just connect to whatever software is running it. So, yeah, let's have a quick look at the control software page. So this is the what was the name of it? The
SurePath, the SurePath.
SurePath, right.
A couple of looks at what that looks like. This. Yeah, it's conceptually it's fairly simple. We take the customer's CAD layout of their facility and upload to the vehicle, and the vehicle basically drives around the facility and maps itself. Then we overlay those the map that it produces with the map that's given, so that it's lined up. And then from that point, once you've established that it knows the facility and that it understands where its waypoints are and how to navigate, then it's very simple to set up your routes and say, go, from point A to B or D or E or Z. You can control it ultimately, because it is like a person. It understands the environment that it's in, and it knows where it can go and where it can't go. And then you can certainly constrain it to various routes. You can give it autonomy to go between, choose route A, B, or C, depending on how it needs to get its job done. So the idea with a controller of this size or this type is to be flexible, to be very, very powerful. And we've laid it out in an open architecture format that we can put enhancements in it for communication, for up and down communication from the vehicle, for operator interface, user interface, integration into different types of other robotics and other plant level equipment. We've got to have that level of flexibility to be attractive to today's manufacturing environment. It can't run on an island and expect to be as efficient as it could be. Now, there you go.
I don't remember AutoGuide's website from before Teradyne took over, but it looks really good now. I mean, there's loads of things.
Yes, we've got we've done some work on it to really try to highlight it in a fashion that people can understand what it's. And watching you go through it, I can see that it is flowing the way that we pictured it should flow. So that's good to see.
Yeah. I'm just going to have a quick look at case studies. I
Sure.
quite like case studies
Yeah.
generally, and it'd be, if it wasn't for COVID, I'd quite like to go to
Yes.
some of the locations that the companies we talk to, like yourselves,
Hmm.
where
Hmm.
they apply their robotic solutions and write articles based on that really, and take photographs. That's the thing, photographs and video. The whole reason why I enjoy, well, not the whole reason, but one of the main reasons I enjoy this type of subject is that there's so many pictures that are such great sort of make for good video as well. It's all about movement, isn't it? Moving machines, and obviously that's ideal for video. Whereas if you're talking about software, by and large, whatever software you're talking about, whatever company you're talking about, you don't really get a chance to put any visuals onto the page. It's all
Yeah.
abstract stuff. But
Right. Right.
tell us a bit about the case studies or the companies that you worked with and done case studies with.
A little connectivity issues going on, but as long as you can hear me, absolutely. So the the two the two workflows I think that are in most that we sense is mostly in demand today are both in the manufacturing space with large product manufacturing like automotive. Automotive is a great market for us where line side delivery of subcomponents can be timed directly with the main assembly line of a vehicle, for example, and delivering those parts in there. And we're in it at several of the major automotive companies, and we're embedded as a technology partner with them and helping them to be as efficient as they can in automotive assembly. So delivering parts synchronously to a line is a strength of an AMR solution. And if you look at kind of come out from say something as controlled as a synchronous delivery automotive into something much more flexible, you go look at the warehouse space, and so the product delivery needs in a 3PL or a supply chain warehouse are vastly different than an automotive. They're much less predictable up front. They need to be very flexible. The distances between pickup and drop off points are typically not the same mission to mission. So you've got to then have flexibility in there, and you're really your value proposition comes in doing things that involve taking product in long distances in these warehouses on a 24/7 basis and being able to just run more or less lights out in warehousing in a very flexible manner. So we're engaged with several of the largest global logistics companies in automating a lot of their workflows, where it just makes sense to put in AMRs to do these definable missions, albeit not the same mission to mission. And we're finding that the return on those investments are very reasonable. That customers are seeing a high value in freeing up their skilled and responsive and sensitive manual fork truck drivers and talent and to go doing things that really do add value to their own operation. That would be flexible handling of various mixed loads and things that are that are more down the alley of the flexibility of a manual operator, where then you can relegate the repeatable and the long haul tasks to tuggers with trailers, like is on the screen now, or fork trucks that take stuff from the loading dock and put it into racking, things like that, things that are much more mundane, I guess, and don't require the talent and skill of a manual fork driver.
Hmm. Okay, well, it remains for me to ask you about the market overall and as it is now, and how you see it developing or evolving? I'm talking about the warehouse robotics market, maybe, or
Okay.
AMR market, AGV market, whatever you want to call it.
Hmm.
That whole robotic trend that warehouses and supply chains are seeing, or warehouse in particular, I suppose. And how, going forward, do you think AutoGuide will fit into that, or is fitting into that?
Absolutely, yes. The warehousing and logistics market is obviously one of our strategic industry segments that we're focused on. We see it as one that has probably the most potential for growth over the next decade, I guess, as does everybody else. And I read reports consistently that back that up. So I believe we're on board. But where does that growth come from? So where it really comes from is two places, I think. It comes from the automation of existing warehouses that are more or less steady state, but that are having problems, for example, finding reliable workers to come show up and to run the delivery routes in those facilities. It's becoming a real problem, given the labor shortages that we see out there in the market. So in that space, we find a lot of first-time robot users. So companies that previously did not have any robots in their facility at all, in their logistics facility, adopting robots for the first time. So we do a lot of education. We do a lot of pilot demonstrations of technology, and then we begin to automate previously manual operations. So that's sort of one growth area that's really got traction. The other then is the just expansion of the industry itself with the global pandemic that we're coming out of at this point. I think it really did highlight that mail order and online order and delivery methodologies are here to stay, and they're going to grow. And so as they grow, the companies involved in e-commerce and logistics, they're putting up new facilities to handle that want or that need that's out there. And so as they build these new ones, now they have this orientation towards automation up front. So they can plan to automate from the beginning of their design. And so they have nearly, or sometimes completely automated warehouse by the time they go live with deliveries. And in those cases, we find that we have a great influence in helping with the layout of those facilities, helping with the workflows that are built in, helping with the layout of paths and of their incoming and outgoing flows and those kind of things. So we see both sides, the retrofit or the existing facilities, and then the new spaces. We see growth in both of those going rapidly. Sometimes they have different workflows. Sometimes they have a lot of the same workflows, but we're seeing that happen. And then the net result there is that the customer base, the warehouse market itself, is starting to demand and look for new automation in new things that they hadn't maybe automated or considered in the past. And in doing so, that presents even more growth opportunities for us. So we see growth opportunities on many layers within the warehouse and logistics market, and you can kind of expect AutoGuide to be coming out with new features, new products, new solutions to existing problems, and then new ways to really think about an entire warehouse solution for a brand new deployment. Maybe in the past, things were done in a much more serial fashion, and we've concepted and are demonstrating how you can do a lot of these things in parallel, increase the throughput per square foot of the facility, and thus increase profitability of the end user. So we're driving solutions, and our customers' wants and needs tend to give us the biggest hints of where we should be going. And indeed, that's what we look at doing. So as these fleets run around more and more on these floors, you see less and less people walking around, and you see more and more throughput going through with lights out.
It's really good videos. I particularly like the high tugger, the high bay Yeah, sorry, I've forgotten the term for it.
The
High
high
bay.
bay. Yeah.
Yeah, where was that? 'Cause I wouldn't mind seeing it again.
Let's see. I think it's. I don't see it on that screen.
It's
It's
not this
probably
one.
below
It's one of
here.
those. No,
Yeah.
that's a pallet mover. Yeah, I think it was the next. No,
Yeah. The use case on that is very interesting. We developed it with the thought in mind that if you take a high bay racking system, you have now the locations already for the basis of an ASRS, an automatic storage and retrieval system. And so if we have a vehicle, an AMR, that can service and reach those locations, then for us, it's a matter of software. So we came out with a product in 2020 called Inventory Manager. An Inventory Manager working in conjunction with our high bay AMR that you see here that reaches up to 36 feet. We basically turn a standard racking warehouse into a mobile ASRS without all of the infrastructure cost and fixed automation that goes with your traditional ASRS. So this is the ultimate solution then for being able to do this. And then of course, for standard, take away and put away in high bay racking, this vehicle is fully suited as the others are to go, handle those tasks in conjunction with a standard, WMS or mission delivery system.
This is a very nicely made video because the
Thank you.
lighting is very good. They call it color mixing or something in the edit stage. They've done something with it. It's very nicely. Obviously, it's a very interesting technology because forklift drivers are usually probably the human ones I'm talking about. They're probably the better paid amongst the staff in a typical warehouse, and
Yes.
they're probably quite difficult to get hold of, the employ, recruit, and retain.
Yes.
So this kind of solution, it's fairly new, and it's certainly not as widely adopted as maybe should have been or could have been. But now with COVID making everybody more aware of problems and the need to solve them through automation, this kind of thing might become much more popular. Just one last bonus question, if you don't mind. A lot of these robots, as far as I understand it, they didn't have specific standards guiding them for the people who built these machines. They didn't necessarily have standards to work to specific to AMRs, for example, or I'm not sure about AGVs. As far as I understood it, when I looked into it, it was a standard that ISO made that related to, I think, autonomous trucks or some large road-going vehicle, part of which may be applied to this. I know there's been new sort of moves to develop standards, and maybe they're already out. I'll have to look into it. But what do you know about the standards that govern these kind of the robots?
Sure. There are several as the space is exploding, both in the smaller AMRs and in these big ones that AutoGuide deals in. Really, a very proactive approach was taken by the Robot Industry Association's RIA in 2020 to release RIA 15.08, and so that is the new AMR safety standard that the Robot Industry Association developed, and it's quite complete. I've read most of it, and it's a very good one. We also comply with the ANSI B56.5 safety standard as well for this type of equipment that we do. And so, the design standards obviously were built looking at the aisle widths and the payloads and the speeds that are needed out there for solving solutions, and then the specific designs once those sort of packaging things were handled, was to look and make sure that the vehicle does have inherent safety built into it. And as you see in these videos, there's no people around it, so it's not it doesn't act like we think of the traditional cobot where it's working right next to a person all the time, day in and day out. But it does need to be inherently safe. It needs to be fail safe. It needs to be operationally safe. And that's a key driving factor at AutoGuide, and everything that we do as we release these vehicles is safety first. Make sure that they're going to operate safely in these environments. And then as these new specifications come out and new ways of looking and measuring safety, we make sure that we're compliant, that we meet or exceed those standards as well.
Okay. All right, Mike. Well, it's been really very fascinating talking to you, and thank you for your patience with my bonus questions and extra questions and all that. Is there something I didn't ask about that you'd like to mention?
I think we covered it fairly well. I obviously could talk about these all day, but I do appreciate it. It's fun to be at this stage of development of this market, where it's a little bit of the wild frontier still feel to it as we discover new ways to deploy these things. So maybe a year from now, we get back together and we talk about what happened in the last 12 months, and we'll both be amazed.
I hope so. Well, we will be if we, I'm sure we will be. It's already very interesting, very stimulating thinking about all this technology, because it's fairly new, relatively. I know the AGV has been around for a couple of decades, but I think it's only recently that they've become more affordable and more people are more open to the ideas. So that's why the market is moving so fast. The technology is moving so fast, and who knows what's going to happen in a year's time? And there's going to be so many changes. So we'll see. Yeah. We'll get together again and we'll talk. Hopefully.
I look forward to it. Thanks, Abdul.
Okay. Well, in the meantime, thank you very much, and I'll see you again.
All right. Take care.
Day. Bye.
Bye-bye.
Send us an email at sales@roboticsandautomationnews.com to register for one of our many upcoming webinars. And if you'd like us to host your webinar, we have a range of options, including long-term lead generation packages and marketing campaigns. We look forward to hearing from you soon.